Hello everybody, my name is Tyler Mason, and for our engineering computation group project, we decided to take a look at the pass-fail rates for each of the different core classes for the EE curriculum. And to start off with, I wanted to mention just a quick introduction of what we worked with and a couple of our assumptions that we made. So to start off with, we had 4 years worth of data, and we wanted to see how likely it was that somebody would pass the core EE classes. And we assumed that all people that took Circuits 1 would go through until they passed fields, and we didn't consider any other workload that somebody might take. So somebody with a 13 credit workload versus somebody with an 18 credit workload we assumed to be roughly similar. And just a quick overview, we worked with the past 4 years worth of data, so that's 8 semesters, and we considered the probability of passing versus spring versus fall. And then we also considered the probability of distance students versus traditional students. And we also wanted to take a look and compare this to the 4-year plan on the UW-Platteville website.
Hello, my name is Phil Matthews, and I'll talk about the methodology that we used for this project. So in order to obtain the graphs and all the other means and standard deviations and calculations, we used MATLAB to get that data. And so for our definition of failing, we used D and F in your grade for the overall class. Students that withdrew were not counted in those that failed. However, they went into the calculations for finding the probability. And so this probability that we used, the calculation equation, we used the number of students who failed within that section, and we divided that by the total number of students in that section minus those that withdrew. So one of the first classes we looked at was Circuits 1. The probability of failure over the past 4 years is displayed by using bar graphs that show the outliers to the highest and lowest for each section. So the data that we got from this, we had a mean of 27.8% and a standard deviation of 2.35%. Some trends for this is that it stays relatively constant over the past 4 years, and that compared to the other courses, it has a higher probability of failure. So for fall and spring semesters, we compared them against each other, and we found that the fall semester had a 27.8% probability of failure versus the spring semesters having a 28.8%. So it's a 1% difference, which doesn't really play a huge role in real world. And then for streaming versus in person, streaming we found to have a significantly higher probability of failure with 34% versus in person being 27%. So that does play a role in the real world.
Hi, my name is Quinn Mast. The next step in the electrical curriculum is Circuits 2. And as you can see, the first 4 semesters and the last 4 semesters are vastly different, with each of them remaining pretty consistent within themselves. The total failure mean was 22.5% with a standard deviation of 8.9%. After analyzing individually all of the fall and spring semesters, you can see that there's about a 3% difference, which plays a role in our calculations later on in the 4-year plan. And next up is Sam.
Hello, my name is Sam Horstel, and I'm going to present on analog electronics. As you can see from this bar graph, there was a lot of different changes in either the pass-fail rates or the course work. As in fall 15, we have the highest fail rate, and the past 3 years, the 3 semesters have been fairly consistent. The mean on the pass and fail rates is a 21% fail rate, and the sample standard deviation is 6.5%. The probability of failure for the fall and for the spring is significant. It's about 7%, as you can see from this table. And the probability of failure by taking it in person or online is not significant. It should be noted that only the online section was offered in the fall, which might impact a role from the last slide where the fall and spring had a significance on the fail rate.
So for electric and magnetic fields, we had a fairly large standard deviation of about 11%. But if we average that, we had a mean of about 12.3%. And one thing to note is that we had a large fail rate in the spring semesters as compared to the fall. And we'll take a closer look at that in a little bit. But it is important to note beforehand that we only had data on the electrical engineering sections. So we did not have any data for the engineering physics students that took fields. And looking at the spring versus fall fail rates, again, we see that reflected. So for fall, we had a fail rate of about 6.5% compared to 17% for the spring. And we also had fairly similar standard deviations. So I wanted to go a little bit more in depth into this, so I did a population analysis. So we used each of the semesters as a data set, so a total of 8 data points. And what I did is I set the null hypothesis that the fail rates are equal, which I try to disprove by saying that the spring fail rate is higher than the fall fail rate. And because it's one-sided, we could have a rejection criteria of the T0 needs to be greater than T of alpha with the 2 data samples minus 2. So using the equation in the top left corner, first I did it with assuming that the delta would be 0 or 0%. And with that, we had a 90% confidence interval that the fail rate in the spring would be greater than that of the fall. And changing that to the delta to 5%, we had a 75% confidence interval that the fail rate of the spring would be greater than that of the fall. And then moving on really quick to the online versus in person, and we had a very significant change. So we had 23% fail rate for people taking it online versus 16% taking it in person, which was quite significant. But we do have to note that only a spring section online course was offered.
So for our next class, we looked at engineering computation. So one thing to note about this class that before the spring of 2017, it was not a core curriculum class. And so it was only offered like once every few semesters. So for this, we found the mean for the probability of failure to be about 7.6%, and the standard deviation about 6%. So some trends with this is that it had a really high failure rate before it was offered as a core curriculum class, and then in the past year or so it went down a lot, so it was really low. However, in the past year, so spring of 2018, it jumps up significantly again, and so it doesn't have a very constant pattern for probability. And then for looking at the fall and spring, there was about a 3% difference, and it wasn't huge, but it's still a factor in that. And then online versus in person, again, about 4%. For this class, though, taking it online did have a significant lower percentage.
Next up is signals and systems. As you can see by the bar graph from MATLAB, it kind of represents a parabolic curve. With more recently, the failure rate has increased quite significantly since spring 17. The mean failure rate was 22% with a standard deviation of 5.9%. After comparing the fall and spring semesters for signals, the fail rate was pretty consistent, around 21 and 22%, not much of a difference, which will be used later on in the 4-year plan.
So for logic and digital design, we kind of had a boring fail rate over the past 4 years with a mean of about 10%, which is roughly average, and then a smallish sample standard deviation of about 5%. We do have a little bit higher outliers on some of these semesters, but it's nothing too crazy, and it didn't really affect our sample mean. And then the probability of failure for fall versus spring was fairly comparable, with a 7.5% fail chance in the fall and 11.2% fail in the spring.
So after looking at each class's probability of passing and failing, we wanted to look at the electrical engineering course recommended path, which is to take Circuits 1 on your second semester of your freshman year, followed by Circuits 2 the following semester, and down the course we go. We wanted to note the difference between taking it in the spring and taking it in the fall. So Quinn will then do some more probability on the passing of taking on the 4-year plan.
Using our calculations, we had our data represented 2 independent events that were not connected whatsoever. So our first issue with solving the parallel combination of taking 2 classes at a time for both the spring and the fall 4-year plan was our main issue. So we found a site on Khan Academy, a video, which stated that we could use the same equation as combining 2 parallel resistances. And by using that, the probability of passing analog and logic is down here noted at a 42.68%. And furthermore, taking engineering computation and signals and systems combined to a 42.19% pass rate. After analyzing all of the pass rates and combining them and multiplying them all together, we can see that starting in the spring semester with the 4-year plan, passing all of the core classes for electrical engineering ends up with a probability of 8.29%. After analyzing with the same equations and combining them all together, starting in the fall, you can see that it lowers your percentage quite significantly with a 2% difference, which is a huge difference between 8 and 6%. So we came up with our own solution for computer emphasis students. This would only be possible for computer emphasis students since analog and signals are great prerequisites for engineering or electronic communications, controls, and power. So to significantly increase your probability of passing all of the core classes first time through, you can see that if we took them all, no matter what order you take them in, but if you take them all in series, your probability will almost triple with the 19.1%.
Some of the trials that occurred while presenting for this presentation was calculating the overall probability of passing. We started by using the stability equations, and after talking to Dr. Buechler, we realized that what we were calculating was not true. And so we outsourced and did a little bit more research and found an equation to combine parallel probabilities. Another huge hurdle was getting permission to use anonymous student grade. There was a lot of legwork done by Dr. Buechler and Dr. Seeley to get us approved to have the grades for this course and present on this data, as well as providing us that data. Some of the conclusions that we can state is that distance students have a harder time passing their courses than taking in class. Another conclusion we can take away from this presentation is that the EP department when they present the fields course in the fall has a higher pass rate than the EE department does. The probability of completing the 4-year plan is relatively low, and it's a tricky course load. And by taking it in series with the way that we suggested earlier, will almost triple your probability of passing. Thanks for your attention, and here is some of our sources